Hey everyone, and welcome. Today we're going to dive into something you see every single day, things moving. Why do some things just zoom by while other things seem to just crawl along? Well, let's get into it and uncover the secrets behind the need for speed. So, check this out. On one side, you've got this big, heavy truck, probably chugging along pretty slowly. But on the other side, whoa, you've got these sleek, fast race cars just absolutely flying around the track. The difference in speed is, pretty obvious. But the reason why they're so different, now that's where things get really interesting. And that right there leads us to the big question for today. What in the world makes one vehicle crawl and another one just blast off? The answer, it turns out, is this powerful, invisible thing that is literally all around us all the time. Let's go find out what it is. Okay, so if we really want to understand speed, we've got to start at square one. What makes anything move in the first place? Seriously, it doesn't matter if it's a car, a baseball, or even you walking across the room. The exact same principle is at work. And here it is, the secret ingredient: force. That's the huge idea for today. A force is really just a simple push or a pull on an object. That's it. Every single movement you can think of, from a leaf gently falling from a tree to a massive rocket launching into space, it's all caused by forces. So let's break that down real quick. A push, well, it moves something away from you. Think about pushing a toy car across the floor. And a pull does the exact opposite. It brings something closer to you, like when you pull a wagon behind you. See? Super simple, right? Pushes and pulls. That's the whole game. All right, so we get it. Forces make things move. But how does this get us back to our race cars and trucks? How do forces actually create, speed? And here's the really crucial part. Forces don't just start and stop things, they can also change how things are moving. A bigger push can make something go way faster, while a force pushing in the opposite direction can slow it right down. This idea is the key to, well, everything. Now, talking about it is one thing, but seeing it for yourself is a whole lot more fun. So let's all be scientists for a minute and run a super quick experiment with stuff you've probably got lying around the house: a toy car and a couple of books. So here's our setup. We've got this cool little yellow car and a simple ramp that we just made out of some books. We're going to see exactly how different forces change this car's speed in a really clear way. Okay, here's the plan. First, we're going to try to push the car up the ramp. Pay attention to how that feels. Then we'll just push it on a nice flat surface like the floor. And last but not least, the fun part, we're just going to let it go from the very top and watch it roll down the ramp all by itself. All right, the experiment is done. Time to look at the results. So out of those three things we did, pushing up, pushing on the flat, and letting it go down, when do you think that little car was moving its absolute fastest? Yep, you got it. It was fastest by far when it was going down the hill. And that's because there was a special force giving it a little help: gravity. Gravity is this invisible pull that's always pulling everything down. So it was working with our car, yanking it down that ramp and making it go super, super fast. Okay, so that was the fastest. Now for the flip side of the coin. When was the car moving the slowest? Or, when was it the hardest to push? Exactly. Pushing it up the hill was way tougher. And why? Well, because you were literally fighting against that very same force of gravity. You had to push the car forward while gravity was trying to pull it backward, down the ramp. This is a perfect example of how forces can work against each other and slow things down. This whole idea of using pushes and pulls isn't just for science class. It's actually how some of the coolest toys work. Let's check out a couple of awesome examples. Take a look at this classic bouncy toy. When you push the little guy down into the box, you're actually squishing a spring inside, storing up a bunch of energy. And then when you let it go, boing! That spring releases all its energy in one powerful push, and it launches the toy straight up into the air. Now, what about this one? A balloon-powered car. This is such a great example of a push force. When you let the air escape from the balloon, the air rushes out backward, and as it does that, it actually pushes the car forward. Pretty neat, right? And here's basically how it works. You just attach a balloon, blow it up through a straw, and then let go. Whoosh! All that air escaping creates a force, a really steady push that sends your car speeding right across the floor. All of that speed just from a simple push from the air. So, we've seen that forces are absolutely everywhere, making things speed up, making them slow down, and just generally making them zoom all over the place. And now it's your turn to be the scientist and start looking for all these pushes and pulls out there in the world around you. So, look, if you only remember one thing from all this, let it be this right here. This is the big idea. Forces can make objects move faster or slower. The next time you see a super fast car or a slow-moving bicycle, you'll know that the secret to their speed is all about the pushes and pulls acting on them. And I'll leave you with one last question to chew on. Thinking about everything we've talked about, what do you think would happen in our ramp race if we swapped out that little light toy car for a bigger, much heavier one? Would it be faster? Slower? Give it some thought and keep on exploring. Thanks for watching, and we'll see you next time.